Hello viewers, welcome to Civil Learning Online, and today in this video I will be discussing about one of the most viral topic, that is the shear force and bending moment diagram on the varying load. As most of the student faces difficulty on the numerical related to the varying load, so I have selected this topic, and students, please do watch the video till end, because from this single video you will be able to clear all your doubts related to the shear force and bending moment diagram related to varying load. So without any further delay, let's get started, and let us begin our numerical. So here the statement or the question is, the beam of length 6 meter is simply supported at its end. It is loaded with a gradually varying load of 750 Newton per meter from left hand support to 1500 Newton per meter to the right hand support. Now construct the shear force and bending moment diagram and find the amount and the position of the maximum bending moment over the beam. So it is the question. Now let us draw the given beam and solve it step by step. So guys, here is the beam of length 6 meter and it is simply supported, as you can see the support is simply supported at its end. Let the end be A and B. It is loaded with a gradually varying load of 750 Newton per meter from left hand support. This is our left hand support, and here the loading is 750 Newton per meter, and it is gradually varying from left hand support to 1500 Newton per meter to the right hand support, and this is our right hand support, and here the load becomes 1500 Newton per meter. This whole length is 1500 Newton per meter. Now let us join these two loads with the help of ruler. Now guys, this is the loading as per the question. Now let us divide the loading into two parts, then let us see what we get here. So guys, now you can see here this 750 Newton per meter is uniformly acting all over the span of this 6 meter. And if we subtract, this whole was 1500 Newton per meter, and if we subtract this portion, this much portion from this 1500 Newton per meter, then the value of this portion will again be 750 Newton per meter up to here. Now guys, 750 Newton per meter, let me show you, that is 750 Newton per meter. Now the UDL is uniformly acting on the beam AB of span 6 meter, and the varying load is this portion, this triangular portion. This triangular portion is our varying load, which is 0 at A and 750 Newton per meter at B. Now this was our diagram and the question. Now let us move toward the step 1, and in step 1 we will be calculating the reactions. So let us first write down the step 1 and then we will find the reactions. Now here comes step 1. Calculation of reactions at the supports. So let us assume that let the reaction at A, B are A and reaction at B are B. What I said, let the reaction at A is RA and the reaction at B is RB. Now guys, let us apply some conditions, that is summation Fx equals to 0, means the sum of the forces in horizontal direction. As you can see here in the given beam there is no any horizontal forces, so obviously our sum of forces in horizontal direction will be 0. Now let us apply another condition, that is summation moment, and I am taking moment at A equals to 0. So if we take moment at A equals to 0, then what we will have, taking moment about A, taking moment about A. Now guys, for taking the moment we have to follow a sign convention, and the sign convention is this is anti-clockwise, which will be taken as positive, and this is clockwise, this is taken as negative. And we can consider the sign convention of either RHS or LHS. It is up to us. Now if I am taking moment about A, and let us take RB as anti-clockwise. So if I take anti-clockwise as positive, then we will have here, taking moment about A, RB into 6 minus, this is anti-clockwise. Now this UDL and the varying load is acting downward, so these two forces will take negative direction because I am following the sign convention of RHS. So now guys, see here, this is our UDL, and the UDL is 750 Newton per meter from A to B, so it will be 750, this is UDL. If we multiply this UDL by span, then it will be get converted into point load. Now this whole becomes the point load. Now multiplying the point load with the span, which is half of the span, then it will gives us moment of the UDL. That is what I said, now this get converted into point load, and if we multiply this by half of the span, means 6 divided by 2, then it will gives us the moment of the UDL. Now this was for UDL. Now let's move toward the varying load, and the varying load is 0 at A and 750 Newton per meter at this end. So guys, the loading of this varying load will be given as the area of this triangle, and we know that area of triangle is given by the formula A equals to half into base into height. This gives us loading of varying load. So guys, now we will have here half into base, means the 6 meter span of this triangle, of our triangle, 6 into height. Now guys, height means this portion, and we know the value of this portion is 750 Newton per meter, 750 Newton per meter. Now this is our loading, we need to multiply this by span. Now most of the student faces confusion here, that what should be the span that we should take. So listen carefully. Suppose this is a triangle and its span is, lower portion span is x. Now guys, if we are finding moment about this point, about point A, and if we are finding moment about at point A, then the CG of this triangle lie at this distance. If we are finding moment about point A, then CG of this triangle lies at 2x by 3. This is, do not get confused, never get confused. Let's watch this carefully. If we are finding moment about point A, and see guys, always remember, always suppose that B is heavy portion. Heavy portion means this will fall go down. This is just a trick, just watch it. It will move faster, it will move downward faster. So the CG is at CG from A will be at 2x by 3. Now if we are finding the moment about B, then the CG will be at distance x by 3. What I said, if we are finding moment about point B and the A portion will slide down about point B, and this here A is lighter than B, so here 2 will not be applied and simply it will be x by 3. I hope you got this concept. Now we are taking moment about A, and this is our heavier portion, so it will be given as 2 by 3 into whole span 6 meter will be equals to 0. So on solving this we will get RB equals to 3750 kilonewton. Now after finding the reaction at B, let us find the reaction at A. For that we will be using a separate condition, that is sum of forces in vertical direction equals to 0. That is equals to sum of forces in vertical direction means upward force minus downward force will be equals to 0, and upward force means RA and RB is acting in upward direction, so RA plus RB minus downward forces. Now guys, this is 750 Newton per meter UDL, and if we multiply this by span, then it will give us the point load, which will be 750 into 6 acting downward minus UDL. The loading of this UDL will be given by the area of this triangle. So half into base means 6 into height is 750 Newton per meter, and this whole sum will be equals to 0. Now guys, here put down the value of RB plus 3750 minus 750 into 6. Solve this and find the value of RA. So guys, this is the value of RA equals to 3000 kilonewton. Now let us find the reaction at the supports, and that will be our step 2. We have calculated the reaction at supports. Now let us move toward the step 2, and in step 2 we will be calculating the shear force on the beam. So guys, watch this step very carefully, and here we will be calculating the shear force at different points. First of all, let us begin with the support B. So I am going to write here shear force on RHS of B, means shear force on the right hand side of B. Now guys, while calculating the shear force at RHS of B, we will have here, while calculating the shear force at RHS of B, just cover the support. So and on RHS of B there is no any loading, so the shear force on RHS of B will be equals to 0 kilo Newton. Now shear force on LHS of B. Now guys, while calculating the shear force on LHS of B, what we need to do is we have to cover the all the portion except this support B, and the support we are calculating this shear force on the LHS of B, means we need to consider this support. The point at which we are calculating the shear force, that should be considered while calculating the shear force on LHS. So here the reaction RB will be considered, and we know the value of RB is 3750, and using the sign convention for the shear force, that is minus minus plus plus. So guys, if I consider the sign convention of left hand side, means upward force negative and downward force, upward force positive and downward force negative, then our shear force on B will be equals to plus 3750 kilonewton. Now calculating the shear force on RHS of A, while calculating the shear force on RHS of A, what we need to do is we have to cover the support A, and the shear force which is coming from B will also be considered, and these two loading which is acting downward will also be considered. So first of all, let us write the shear force which is coming from B, which is 3750 kilonewton positive. Now guys, see here, this shear force from B is acting upward, and these two forces of loading due to the UDL and the bearing load is acting downward, and for downward we will be using the negative sign, means minus, and the loading due to UDL will be minus 750 into 6 minus half into base 6 into height, means 750. This is the loading due to UDL and this is the loading due to bearing load, and on solving this we will get the value of the reaction on RHS, shear force on RHS of A, which is equals to minus 3000 kilonewton. Now let us calculate the shear force on LHS of A, and for calculating the shear force on LHS of A, what we need to do is we have to bring the shear, we have to consider the shear force which is up to the RHS of A, because while calculating the shear force on RHS of A, what we have done, we have covered this support A. So up to here the shear force is minus 3000 kilonewton meter, so it will also be considered here. Now guys, for calculating the shear force on LHS of A means we have to move away from that point. Always remember the point at which we are calculating the shear force on its LHS, then we have to move away from that point. Likewise at B also, what I did, I was first, while calculating the shear force on RHS of A, I was standing on point B, and here on RHS of B there was no loading, so the shear force at B was 0. Similarly, while calculating the shear force on RHS of A, what I did, I was standing on point A and I have considered all the load which was visible in the diagram. Now while calculating the shear force on LHS of A, what we need to do is we have to move away from that point, and the reaction at that point is visible from the diagram, so we have to consider this reaction, and the reaction is acting in downward direction, and from the sign convention it should be taken as positive, so positive, and the reaction at A is 3000 kilonewton, so it will be plus 3000 kilonewton, and on solving we will Newton. These all loads are given in Newton. As per the question, all loads are given in Newton, so here the reaction shear force on LHS of A will be 0. Now see here guys, carefully, here this is our step 3, and in step 3 we are calculating the moment, and the support is hinge support, so obviously the moment at the hinge support is 0, that is moment at A will be equals to 0 and moment at B will be equals to 0. Now guys, from the question is we are asked to find the maximum bending moment. Now we have to locate, and also the point where the bending moment is maximum. So guys, remember one thing, that the point where shear force equals to 0, at that point bending moment is maximum, means the point where the shear force is 0, the bending moment is maximum at that point. I repeat, bending moment is maximum at the point where the shear force is 0. So guys, let us suppose at distance x from A the shear force is 0. I have considered that the shear force is 0 at distance x from the support A. Let me write it here. So guys, I have considered that the shear force is 0 at distance x, and let this point be C. So guys, it means if we calculate the shear force at point C, then it will be 0. then the shear force will be, if I take upward positive and downward negative, then it will be written as, see here guys, carefully see this step carefully. What I said, I am taking upward force positive and downward force negative, so it will be RA, that is acting down upward, and the UDL is acting downward, and the span is x meter, so minus 750 into x. Now guys, here in this diagram we know that the loading value is 750 Newton per meter up to this portion, but we don't know the value of this portion. Let this be denoted by Z. Now guys, see here we will be using the law of similar triangle, and the similar triangle says that, see here guys, law of similar triangle says that the sides of the similar triangle are proportional. Means sides of similar triangle means smaller triangle side, that is Z by this 750 will be equals to this x, that is span, this lower span is x meter, so x by, and the whole span is 6 meter. That is nothing, I have considered this triangle and this whole triangle, this is Z by 750 and x by 6 meter. From here we will get the value of Z on solving this proportion, that is Z equals to 750 x by 6, and we will get Z equals to 125x. Now we have got Z equals to 125x. Now let us take the value of this shear force of due to or the loading due to this portion. It will be minus, as it is acting downward, half into base is our x into height is our 125x equals to 0, because we have considered that the shear force is 0 at distance x equals to 0, means sum of all the forces up to that point C will be equals to 0. From here put down the value of RA and solve this to get the value of x. So guys, this is our equation. Now let us solve the equation using calculator. Click mode and then press 5, and then select the equation of the form ax square plus bx plus c, which is our third type. So enter 3. Now enter the value 62.5 equals to 750 equals to minus 3000 equals to, press again equals to, and the value which we get is x equals to 3.165, or this is my negative value minus 15.16, and we all know that the distance cannot be negative, and here the x is our distance, so this value is neglected, and we will move with this value, which is our x equals to 3.165. Now this was the point where our shear force was 0, means this is the point where our bending moment is going to be maximum. So let us find the moment up to that distance x, that is our point C. So moment at C will be equals to 0. Again, moment at C will be equals to 0, means RA into 3, or that is x, if I am taking clockwise as positive and anti-clockwise as negative. RA is taking clockwise direction and I am taking clockwise as positive, so RA into x minus, and these two loads are taking anti-clockwise direction, so minus 750 into x by 2 minus, and the loading of this portion is half into base into height into. Now guys, I am taking moment about C, and the CG, I am taking moment about C, and this light portion is moving downward, means I will not take 2, then it will be simply x by 3. See guys, I am taking moment out C, and this is our lighter portion, so eliminate 2, and then it will be this L by 3, that is x by 3. Now from here we will get put equals to 0. Now put down the value and calculate the value, put down the value of x and calculate the value of the maximum moment. So guys, this is our final moment. Now let us draw the shear force and bending moment diagram, which will be the final step of this video. Guys, this is our end A and this is our end B, and we have calculated the reaction at A as 3000 Newton, because our loading was in Newton. I have mistakenly written it as kilonewton. It will be Newton because the given load is Newton per meter, so sorry for this. And this is suppose this is our 3000 Newton per meter, and the reaction at B is 3750 Newton. So let us make it as negative, that is 3750 Newton per meter. And in each and every beam there will be a condition which when our shear force will be a 0, and due to this varying load, and suppose our distance x was here where the shear force was 0, as we have considered that our distance x was from the point A at distance x, and this was our 3 point, let me check the span here. We have calculated the value that our at distance x from A the shear force was 0. So make it hogging, this is positive, so make the positive value as hogging, and this slightly depressed up to here, and this is our shear force diagram. Now time to draw the bending moment diagram, and let us draw the bending moment. And this was our A and this was our B, and the moment at the support due to the hinge support is 0, and we have calculated the maximum value of the moment, which was 5078.13, and this will take the parabolic form or hyperbola, 5078.13 Newton meter, and this is Newton. Shear force is in Newton, and this is Newton meter moment. Now I hope this video was very helpful to all of you guys. Stay connected with Civil Learning Online for more videos related to civil engineering. Do like and share this video, and see you in the next video. Till then, have a nice day. Thank you.